So that's the first of our memory optimizations, changing the number of buckets for the string pool. I'm going to, in this chapter, just look at a couple of other small changes that we can make using flags. We are going to look at more of these in a little while once we've done some work on garbage collection. But I think it will be worth now just looking at the size of the heap. If you recall, the memory space that Java has is split into stacks, the heap, and the meta space. So we'll just look at the heap for the moment. And remember that the string pool, ever since Java 8, lives in the heap. So the heap must be at least big enough to store the footprint required by the string pool. In our case, that's 800 megabytes. Now, to find out the size of the heap, I hope you'll remember from earlier in the course, one of the ways we can do that, and this is the reason I'm using Cygwin, is because we'll need to be able to scroll back to find out the answer, is by running java-xx : plus unlock diagnostic VM options, and then another flag -xx : plus print flags final. That's going to give us all sorts of information, and we'll need to scroll back to find the ones that are relevant to us. And the two that I want us to look at right now are max heap size, and on my machine that is this number here. That is in bytes, and I think that is roughly 4 gigabytes. And the other flag is initial heap size, so I'm just going to scroll and find that one. And here it is, initial heap size, and that appears to be around about 260 megabytes. I think that's what that number is. It's very difficult reading these large numbers, but that's certainly in that sort of ballpark, about maybe probably 264 megabytes, something like that. These default settings, the initial heap size and the max heap size, will be based on the hardware that you are using, the amount of physical memory in your machine, and which version of the JVM, whether it's the 32-bit or the 64-bit version. These can all impact these numbers. So it's worth looking up what the defaults are for the hardware where you're going to be running your application. But clearly, the overall heap size, being around about 4 gigabytes, is definitely big enough to hold this application's footprint that's needed of around about 800 megabytes. But we can change these values. So just to see what would happen if we do that, I'm just going to go back to the previous command that was printing our string table statistics. I'm going to leave this flag in to have a bigger string table size so it runs a little bit quicker, and I'll add in another flag. I think actually I'll do this one at the beginning, which is going to be to change the size of the heap. So the flag to do that is -xx:. This one is max heap size. And let's set that to 600 megabytes, which is definitely going to be too small. So we want our application to run, but there won't be enough space in the application to run it. So I'm going to start that running. And we know that our string table needs more than the available heap that's going to be in our application now. So I expect that this is at some point going to crash with some kind of out of memory error. That may take a while, so while it runs, I'm going to talk a little bit more about this flag. Clearly, when we're trying to optimize our applications, we don't want to do what I'm doing here, which is setting the flag to be small. We'd want our flag, the maximum heap size, to be big enough to hold the memory requirements of the application. Actually, I'm just going to talk about this for a moment. There is a default max memory size, as we've seen. In my example, it's 4 gigabytes. If I'm writing an application which needs more than this, then setting the max memory size to be sufficient will obviously be a very important step, or my application is going to crash. I'm not sure if I'd really call that tuning as such, but it's obviously something we need to know about. But here's the important point. We've got here, I hope, an out of memory error. Yes, we have. If when you're running your application and you get an error like this, an out of memory error in the Java heap size, then the first thing to do is absolutely not just use this flag to increase the heap size. Normally, an out of memory error like this actually means that there's some kind of problem. Often it's something called a memory leak, and we will be talking about these very soon. So don't just use this flag, max heap size, to increase the size of your heap if you get an out of memory error. In fact, the way I normally use this flag is to do what I'm doing right now, is to lower the size of your heap for testing purposes to make sure that your application is running efficiently. Okay, but we have had this crash. It took quite a while to happen, and we'll understand why it took so long when we talk about garbage collection. But we've seen then that we can change the maximum heap size should you wish to, and the default value will depend on your specific hardware. The other flag is the initial heap size. So when your application starts, Java requests from your operating system the initial heap size amount of memory. It doesn't request the maximum because, of course, it might not need that maximum. On my machine, the maximum is 4 gigabytes normally, and it will be rather wasteful for my application that doesn't need 4 gigabytes to request or reserve that much memory from the operating system. So when it starts, it requests, I think it was about 260 megabytes, and then as it needs more, it requests more until such time as it's got enough. In this case, it would be about 800 megabytes. Now, this process of requesting more memory when it's needed isn't normally something that's of great concern from a performance perspective, but it might have an impact. So one thing we can do is tell the Java virtual machine to start with a higher initial heap size. Because I know this application needs 800 megabytes as a minimum, it might make sense to say, let's start this application with an initial heap size of 1 gigabyte. Then we know that the application should be able to run without that need for resizing, and there might be a slight performance improvement by doing that. So let's see if that's the case in this example. Before I run this, I'm just going to scroll back up to the last version that ran, if I can find it. That was here. So the last time we managed to run this successfully, it took just under 28 seconds. So I'm going to run this again. And this time, rather than setting the max heap size to be 600 megabytes, we don't want to set the max heap size anymore. What we want to do is to set the initial heap size. And I want that to be 1 gigabyte, so 1G should do that. So again, I'll press enter, I'll let this run off camera, I'll resume recording in a moment when it's finished. And that has just finished, and we've gone down from just under 28 seconds to about 23.5 seconds. So it turned out there was an improvement in this example by setting a higher initial heap size.